Hello everyone and welcome to Nutrition 1. In this video we're going to be going over Chapter 1, which is an overview of nutrition, and it's going to talk about many of the concepts that we're going to describe in more detail later in the course. So, let's begin. Why do we eat what we do? Why do people select the foods that they do? They do so for a variety of different reasons. One of them is personal preference. As you might expect, the number one reason that people choose the certain foods that they choose to eat is because of taste. They like the flavor. Two very widely shared preferences for food all across the world in every different culture are those for salt and those for sugar. Fat also appears to be a very universally common preference. A second reason is habit or tradition. Maybe you're one of those people or you know somebody that eats oatmeal for breakfast every morning just because they always have. Habit and tradition are a really strong reason also that people choose what they do because not having to make difficult decisions can sometimes be comforting. Another reason is social situations. Many people like to go out with their friends or with their family to eat, and meals are social events, and the sharing of the food is an important part of that. And this is related to social customs, where people will invite people over for food, etc. Another reason is availability or convenience. Many people often eat the foods that are accessible to them, the ones that are quick and easy to prepare. Maybe, if you're on campus and you didn't bring your lunch, you're just going to go for whatever's in the vending machine, and this is related to the availability or the convenience of the food. And we kind of already talked about convenience. And another one is economics. We'll find as we explore more throughout the book that one of the biggest reasons for health disparities is that people without enough money don't have access to healthier food. So if you'll tend to choose to eat what you can afford to eat. Another one is emotional comfort. Many people eat out of loneliness, out of maybe boredom, depression, to calm anxiety. And this is one of the things we're going to talk about when we talk about weight management and learning how to develop healthy coping skills rather than turning to food for emotional support. Another one is body weight and image. Many people try to control their body weight or their body image by choosing what to put into their body. And we'll explore this a little more again in the weight management chapter and when we talk about eating disorders. And the last one we have here is for nutritive value, for good nutrition. So now that we've discussed a little bit about the different reasons people to choose to eat what they do, now we can talk about how our daily food choices will either benefit our health or harm our health. Now, it's true that some people can make very poor food choices and live long, healthy lives and never be at risk for chronic disease. But for the most of us, what we eat does impact our risk for chronic disease. And by chronic disease, I mean a disease characterized by a slow progression and a long duration. This is in contrast to acute diseases. An example of something acute might be something that only happens for a short period of time. But a chronic disease is something with a long duration. So something like diabetes, heart disease, and some cancers, those are all chronic diseases. And then when I say the word diet, I don't mean a specific eating plan. I just mean in general what types of foods and beverages you choose most often over the course of time. Now here are the 6 classes of nutrients. We have water, minerals, vitamins, carbohydrates, proteins, and lipids or fats. Now, the 6 classes of nutrients can be classified in several ways. One is whether they are organic or inorganic, and by organic I mean their structure contains carbon, and by inorganic I mean it does not contain carbon. And another way to classify them is whether or not they yield energy. So carbohydrates, proteins, and lipids all yield energy. And because the body requires these in larger amounts, they're sometimes referred to as the macronutrients. But minerals and vitamins are referred to as the micronutrients. And while they don't yield energy, the body requires them in order to perform the chemical reactions that do yield energy. So important to know, the nutrients that are organic, meaning carbon containing, are the carbohydrates, the lipids, the proteins, and vitamins, whereas minerals and water are inorganic. They do not contain carbon. And as we'll learn about later in the protein chapter, protein contains nitrogen, and that's what makes it different from the other macronutrients. Now we can see here that the body composition of us is actually sort of similar to the body composition of food. We have a greater percentage of water and then fat, and the remaining portion of our body is carbohydrates, protein, and vitamins and minerals that make up our tissues. And as you can see from this slide, women have a higher percentage of fat than men, and this is because they are the ones that will bear children. Now we can see this table breaks up the 6 classes of nutrients, and notice that the organic nutrients are the ones that contain carbon. So we have the carbohydrates, the lipids, the proteins, and the vitamins. And important to note that nutrients that must be supplied by the diet, that we must get through food, are known as essential nutrients. They're not essential simply because the body needs them, but they're also needed from outside the body. So we need to get them from foods or supplements. So remember, the macronutrients are a source of calories, a source of energy. So carbohydrates have 4 calories per gram. Fats are more energy dense with 9 calories per gram. They have a higher energy density. Alcohol does yield energy, but it's not a nutrient. And this is because alcohol does not sustain life, and it interferes with the body's normal growth and maintenance and repair processes. So it's not a nutrient, even though it does yield energy. It has 7 calories per gram. So you see fat has 9 calories per gram, meaning it's more energy dense. The energy in 1 gram is more than that of protein and that of carbohydrate. Carbohydrate has 4 calories per gram, protein has 4 calories per gram, fat has 9. So consuming lower energy density foods can contribute to weight loss, and this is because per the volume of food, you're just going to be getting less energy. So let's look at how to calculate the energy that you'll be getting from foods. So let's say you had a bean burrito with cheese. If this bean burrito had 55 grams of carbohydrate, CHO stands for carbohydrate, 15 grams of protein, 12 grams of fat, let's figure out how to calculate how many total calories are in the meal and the percentage of those that are from fat. And if you want to look at how to do this, it's in page 10 in your book, but let's go over it right here. So if you have 55 grams of carbohydrate in this bean burrito, you multiply that by 4 calories per gram. So 55 times 4 equals 220. Then let's go to protein. 15 grams of protein times 4 calories per gram of protein equals 60 calories. Now let's handle the fat in this bean burrito. There's 12 grams of fat, and then again, fat has 9 calories per gram. So 12 times 9 equals 108 calories. So we have 220 calories from carbohydrate, 60 calories from protein, and 108 calories from fat. So we add these all up together, 220 plus 60 plus 108 equals 388 calories. That's the total calories in the meal. Now, what percentage of the calories are from fat? So we had 108 calories from fat divided by the 388 total calories times 100 to get a percentage. So we get 0.28 times 100 equals 28% calories from fat in this bean and cheese burrito. So what you do is you take the grams from each macronutrient, carbohydrate, protein, and fat, multiply it by the number of calories per gram, 4 from carbohydrate, 4 from protein, 9 from fat, add them together to get the total calories, and if you'd like to find the percentage of calories from any macronutrient, divide the calories from that macronutrient by the total times 100. So when the body uses the macronutrients to produce energy, the bonds between the nutrients atoms literally break apart and then release this energy stored in the bond. This energy then can be used, it might be released as heat, but also it might be used to send electrical impulses through the brain and the nervous system. It might be used to move our muscles. It might be used to synthesize different body compounds. So in this way, energy from food supports all our activities, from studying for our quiz to going for a run at the gym, etc. And this energy, if it's not used, ends up being stored. And this is stored as body fat. And this is used in between meals and overnight when our energy supplies run low. So the macronutrients then provide the raw material also for building tissue and regulating body activities when it's not being used for energy. So you'll see later in the book that protein is not really used very much as a fuel source, and this is because it makes up our tissue and it regulates our digestion and our metabolism. So the vitamins, like the macronutrients, are organic, meaning they contain carbon, but they do not release energy, but in fact they facilitate the release of energy. So almost every reaction in our body is going to require assistance from vitamins, and we're going to learn more about each of the 13 vitamins when we discuss the vitamin chapter. And it's important to know about vitamins that they can only function when they're intact because they're complex organic molecules. So they're vulnerable to destruction from heat, like when you cook something, from light, and from chemicals. So this is why the body needs to handle them carefully, and that they need to be handled carefully in the cooking process so that the vitamins remain intact since they're vulnerable to destruction. The minerals also do not yield energy, but they are inorganic. So unlike the vitamins, they are not vulnerable to destruction. They're indestructible. So when iron is an example of a mineral enters the body, it leaves the body in the same way. It remains intact. There's 16 essential minerals. Some are necessary for our body's processes, but others are environmental contaminants. An example of that is lead. And then last we have water, and water is essential for nearly all the body's activities. Pretty much every reaction is conducted in water. It's important for our metabolism, for transporting materials to cells, for carrying waste products away. And we're going to learn more about water when we discuss chapter 12 and 13 later in the course. Now, nutrition is a very interesting science because it has its foundation in several other sciences. It's rooted in biology, biochemistry, and physiology, and it depends on those sciences for its foundation. It's a really young science, but as you can probably see by the size of your textbook and the scope of this course, there's a lot to the science of nutrition, and a lot has happened in the science's very short time span that it's been around. Nutritional science is currently experiencing a very big growth, and this is because of the knowledge that was gained when we sequenced the human genome. So now